Today we're going to be talking about composites, cutouts, and pieces of circles. Our objective is that we will be able to use the formula sheet to identify figures and determine the area and volume of two-dimensional and three-dimensional figures, including practical problems. So composite means that we are going to put together multiple figures. So we're going to need to add pieces together at the end. So in our example, find the surface area of the composite solid below. So we've got a square pyramid on top of a rectangular prism. Surface area means everything outside. Now, normally the surface area of a pyramid would include the bottom, but when we put these two shapes together, the bottom doesn't count anymore. And if you recall, that's actually called the lateral area. So for the pyramid, we are going to find the lateral area. The formula for the lateral area is 1/2 LP. Now it told us that the L, our slant height, is 15, but we need to know the perimeter of the base. Since the top of the box would be the same as the bottom of the box, we know this is 14, 14, 14, and 14. So P would equal 14 times 4, which is 56. So our lateral area is 1/2 of 15 times 56, which gives us 420. So that takes care of the top of the house shape. Now we need the sides and the bottom of the cube. So let's do the sides first. All the sides are going to be the same, and the area of one side would be 14 times 16, length times width. Just like on our rectangle, area is length times width. So one side has an area of 224, but we have 4 sides to the box, so that would equal 224 times 4 sides, which is 896. Now for the bottom of the box, again, area is length times width, which would be 14 times 14, which is 196. So to find the surface area of the whole shape, it'd be 420 plus 896 plus 196, which all together gives us 1512, and then our units were centimeters, and since we're dealing with area, it's centimeters squared. Cutouts. When figures are inside each other, it is necessary to use multiple formulas and subtract. So here we have a spherical ball that has a diameter of 2. So I'm going to label that on my picture. It is dropped into a cylindrical cup with a diameter of 6. So all the way across is 6, and it told us halfway is 3, and a height of 5. Assuming the ball is non-porous, which means it won't suck up any of the water, and will remain at the bottom, what is the volume of water the cup can hold now? So what we're going to have to do is find the volume of the cylinder. We're going to have to find the volume of the ball, or the sphere, and then we're going to subtract them. So volume of a cylinder, if you look on your formula sheet, is pi r squared h. So in our case, pi, our radius is 3 squared times 5. And I'm not going to type in the pi to my calculator right now. It's going to make it easier when we subtract. So I'm going to get 45 pi, because 3 squared is 9. 9 times 5 is 45. For the volume of the sphere, volume equals 4/3 pi r cubed. It told us the diameter is 2, so the radius would be 1. So that would give us just 4/3 pi as our volume. So to find the total volume, or the new volume that's left, we would subtract that. 45 pi minus 4/3 pi. If we type that in our calculator, 45 pi minus 4/3 pi, we get that the volume is 137, because it says round to the nearest whole number, and our units would be feet cubed. So let's move on to our pieces of circles. So important things about circles. We have the circumference of a circle, which is just a fancy word for the perimeter of the circle. So that would go, let me use my highlighter. That would go all the way around the circle. The formula for this is on your formula sheet. It's right here. You can find circumference using radius or diameter. Typically we're given the radius. So the circumference equals 2 pi r. And our units are one-dimensional, so it would just be centimeters, inches, feet, etc. An arc length is a portion of the circumference. So let's say here's our center. We have point A and point B. We might want to know how long the arc is from A to B. Now we previously found the arc measures based on the angles, but we're saying this is a bigger circle, it's going to have a bigger arc length. If it's a smaller circle, it's going to have a smaller arc length. So we want to know just from A to B how long it is in meters, inches, centimeters, etc. We calculate this by taking the circumference and multiplying it by the number of degrees of that angle or arc divided by 360 degrees. So we're going to have to use our circumference formula. A sector basically looks like a pizza slice or a pie slice. And it's asking us how much area, how much space of the circle is taken up by this. So for this, we would multiply the area of the circle times the degrees over 360 degrees. The formula for the area of a circle, again, is on your formula sheet right here, and it's pi r squared. So let's look at some examples. Find the area of the sector that is shaded. So we're going to have to use our sector formula. It's the area, which they didn't give us, so that we're going to have to use pi r squared times the degrees over 360. So bring down the pi. Our radius shown in the picture is 3. Divided by the degrees of the angle and the arc would be 70 degrees over 360 degrees. So let's put that in our calculator. Pi times 3 squared times 70 over 360. And we get that that sector is that would round up to 5.5 feet. And because it's an area, the feet will be squared. The area of the following shaded sector is 49.1. So they're giving us the answer this time. We're going to have to work backwards. Find the area of the circle. So we know that 49.1 is equal to the area times the degrees over 360. Now it gave us the area of the shaded sector, so we need to know the degrees for the shaded sector. Remember, the whole circle is 360 degrees minus the 135 that we were given for the non-shaded area. And that leaves us with 225 degrees. So that's the degree we're going to use here. To get A by itself, you can either divide by 225 over 360 on both sides, or you could have multiplied by the reciprocal. But if we do 49.1 divided by 225 over 360, we get 78.56 centimeters squared is the whole area of the whole circle. Since the shaded part was 49.1, we know that this final answer should be bigger than 49.1. Let's do some arc length problems. So find the arc length of AB. Our formula we said was the circumference, so 2 pi r times the degrees over 360. So 2 pi, our radius is 6, and our degrees for this arc is 135 degrees. Put it in our calculator. 2 pi times 6 times 135 over 360. And then we get the arc is 14.14, and we're measuring in feet. Find the circumference of the circle D. So again, we're going to have to work backwards. We're given the final answer, so 4.19 equals the circumference times 40 out of 360 degrees. So we're going to divide both sides by 40 over 360. Divided by 40 over 360, and we get that the circumference was 37.71 inches. That's all for today. I'll see you in class.